So given an n cross n square, you have to put queens. You have to put n queens, such that they don't attack each other. So a queen, if a queen is here, then she can attack anybody in this file, or this rank, or this diagonal, and backwards, and all. So yeah. So here it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and everything on this file and this rank. Okay. So if I have a queen here, I cannot have a second queen here, here, or here.
Even here and
Yeah. Okay. So now the question is, you have to put n queens, right? So we already know that you can't have two queens on the same file. So you have some queens. So again, I'm trying to push you in the direction of what is the state of a node and what are its children.
State of a node, I don't know how it will start, because if you try to place one queen in one position, only then you will try to see what is the possible place for the second. But
Correct.
When as you go to the results, the first position can also change.
Yes.
So
those are all children. So the empty node is where you don't have any queens. That's why you need to have the empty node.
So you have to place first queen in all possible.
Yes.
In all the traces.
Yes.
So that is the first step.
Yeah. So like ultimate like Hulk brute force is have this queen in all 64 squares. Okay. And then have a second queen in all 64 squares. Have a third queen in all 64 squares. So on. But we just know already with chess knowledge that if you have a queen if you want to put n queens on the chessboard, they should all have their own exclusive files.
Yeah.
I can't have two queens on the same file.
What is a file?
File is a vertical line.
Okay.
Rank is a horizontal. Yeah. And since you have to put n queens, and no two queens can be on the same file, that means by pigeonhole principle, every queen gets their own file.
Are there multiple solutions to this, or it's always one solution?
No, it depends on n. So
for one n,
for n equals 3, I think there's only one solution.
Okay.
No, even for n equals 3, there are two. Yeah, so there will be multiple solutions. So n queens is about finding all solutions and outputting it in a very, very like expensive format. You have to output this. This is such a pain. That's why I picked n queens 2, where you just have to output the number of solutions. So basically n queens 2 is just solve n queens and then get size. That is also one solution. But okay. So now that you know what it is, so this is like a small chess hack coming up with 5. So okay, now tell me, like what do you guys want to choose as a state, and what do you want to choose as children of that state?
State is one queen at one particular.
Well, let's do files. Let's say
File. Okay, column, not the row.
Yeah, column. Okay, I'll just call it column. Yeah.
Okay, it's column wise, is it?
Yeah, you're right. You could also do row wise. It's the same thing.
Okay.
Like you can't have two queens on the same row as well, right?
So in one column, you will try to place one queen in all possible 8 positions. So that is the first 8 children.
Exactly. Awesome. And then its children will be
children will be other than those positions where another queen cannot be placed.
Yeah, but where do you want to put that queen? So let's say are you guys following? So we are talking about the tree for backtracking.
So in first it is an empty node.
Yeah.
The first child will be a single queen placed in all possible 8 possible rows or columns.
Yes, let's put each one queen in one column. Okay. So the first node will have 8 children, right? You try to put the first queen at here, A8, A7, A6, A5, so on up to A1. Okay? That's the first set of children. What is the second layer?
So second is placing the second
queen where?
With the
except for that row and column, it is the first.
Not just the row.
For the second row it will be except for that row and column.
What about the diagonals?
Yeah, diagonal also, whatever.
So it is eliminating all the possible attack positions.
Correct. So now what is the generic node and what are the children? So at some intermediate state I, what is that node?
I'll
So-
just draw it.
Yeah.
So this.
So we have to do 64 for the first
Exactly.
queen, right?
That's what. So we came up with this chess hack.
Hmm.
So for every queen, we only have 8 possible candidates. So for the first guy, there's only 8 possible candidates.
Hmm.
For the second guy, I don't try to put him everywhere. I only try to put him on the second file.
Second part.
Why? Because I know in my end answer, if I want to fit n queens onto this board,
There can be
each
only one
queen gets their own exclusive file, exclusive column.
Hmm.
So yeah, so an intermediate state will be like state I will be, I would have put I queens in I files,
Ah.
and then I need to find a position for the next queen on file I plus 1, column I plus 1.
So we can't put the next queen in any other file except the.
Yes, because by going sequentially like that, I'm decreasing the number of possibilities for every state.
Okay.
You can do it, but
would
it's
the
that's more
solution
expensive.
differ? I'm just.
No,
asking.
solutions won't differ, but it will be
Okay.
more expensive. Solution won't differ even if you try all 64 Hulk brute force for all queens.
Okay, so in that case, if it is ij,
Yeah,
we cannot place it in I plus 1
yeah,
j
Yes.
and
I plus 1 j minus 1.
I plus 1 j minus 1 if we go upwards. Yeah.
yeah.
Those are the only two places where we can't place it.
No.
I mean,
So, okay,
if
hang on.
we fix the first queen, then.
Yeah, you're talking about going from row column 1 to column 2, right?
Yeah.
Yeah, column 1 to column 2 also depends on where you put the first queen. If you put the first queen here, You can't put the
okay.
second queen in one,
surrounding-
two,
the
three.
surrounding blocks, yeah.
yes.
I mean, I told the bottommost
Yeah.
position. If that is up,
Yeah.
then we have surrounding
Yeah.
positions.
That's correct.
But,
But in terms of
we,
coding,
some of the trees will stop in between because there will not be a solution, right? If you place a queen, there will not be a solution at all.
yes,
So
Some of the
will
paths
stop in the
will not lead to an n queen solution, a valid n queen
yeah.
solution. Yes.
So only when that is 8, I mean the count is 8, that is the solution that we
Yeah.
count.
Yeah. Yeah, now my question is, so whenever you're coding, you basically have an idea of what is a generic node, some ijth node or some node in the middle, and how do you go from that to its next.
Hmm.
So what is an ith node again?
So for I,
Or whatever, some node in the middle, what is
for
it?
ij, what are the attack positions?
No. What is a node?
What is a node? Okay.
Yeah.
This list of queen positions.
Yeah, and what are they? List of what? List of what type?
Matrix.
No, okay, first of all, let's talk about abstract concepts. So concept wise, what is a node? Don't go to Java or lists or anything.
Okay.
What is a node?
A node is going to determine one possible n queen position.
No, that is the final result.
State of the chess board.
Yeah, state of the chessboard, but what is on the board? Somewhere in the middle. So I'm sequentially trying to build these
I
n queen
queens.
positions, right?
I queens, right?
I queens, correct. So that means I put I queens, one in each file.
Yeah.
Okay? So that, let's say for this board 4.
Hmm.
So I put this queen, this queen, this queen, this queen. Okay?
Yes.
Now I need to go from only having these 4 queens to having the 5th queen as well.
Yeah.
So what do I need to do for that?
Ah.
How do I know? Can I put the first queen here?
No, just
No, because these two
consider
are-
attack positions of all the 4.
No,
Yes.
only the last queen, right?
No,
No.
all the 4.
Because if you put it here or
It might come
Here.
in that same.
So it will come in attack line of other queens. So
Yes.
you have to consider all possible.
correct. So you take all these 8 positions and see which of these 8 positions are free
Hmm.
from attack from all of these previous
So
4.
all these 4. So we should add up the positions
Correct.
as we fix a position. right?
Yes. Okay, and for going from 5 to 6, then I have more queens now.
Mm.
Now the number of options went down for the
Yeah.
next rank.
Okay.
By whatever, yeah. So, okay, now tell me what is the Java state? How do you want to represent the chessboard?
Boolean matrix.
Okay, and just true, false? Oh, Boolean matrix, okay. Okay, that's fine. But we already know the column for every queen. It's every column that I've encountered so far.
Okay. So it's a Boolean array. I mean, a list of 5 elements. So it's a column wise.
Or maybe a list of pair of queens. the result.
Yeah, see, if you do list of queen pair positions, I always know that the column will be consecutively increasing numbers. So I don't even represent the columns. I already know the columns are consecutively increasing numbers. 1, 2, 3, 4, 5, 6.
Okay.
Right? So what is remaining then?
Row.
Just the row.
Okay.
And what type? I have many rows to represent.
Yeah.
So what is the type? Row is just an integer, right?
Yeah. Integer.
No, tell me. You're right. Be louder. What do you say?
I said integer array.
Yeah, or integer list.
Yeah, integer.
Yeah, whatever.
Yeah.
Okay, but for each row, how do you get the attack positions?
No, right now I want to represent the state of the chessboard, right? So if I give you that list, can you put the queens on the chessboard? I just give you the list of rows.
Okay.
So the list of rows will be 2, 4, 6, 8. If I just give you 2, 4, 6, 8 on a chessboard, can you put the queens?
Yeah.
Yeah, because in the first column I put 2, in the second column I put 4.
Okay.
Yeah, so if I can do that, then I can calculate the attack position.
Position of the queens.
Yes.
Okay.
So your state should tell you where the queens are placed. And for that, instead of pairs,
Okay.
you just do list of integers. But
So I was telling Boolean array for attack positions, not for
yeah.
positions.
Okay. Yeah, you can do that. But that's. Okay, got it. Simple, right?
So how do we calculate the attack positions from this list?
Yeah, good. So now what I do is, right now let's say I'm trying to put a queen on the 5th column. Okay. Now I take this position. So this is one candidate. And now I have 8 candidates, right? For the 5th file. So for this candidate, for this square, I see is this square in attack from any of these queens.
How do you judge that?
How do you judge that? Because you know this queen is on this rank and this file. So you know this rank is gone. And these diagonals are gone.
Okay.
That's just math.
Oh, so at each position you calculate all the surrounding.
Yeah, given a square and some queens, I need to calculate whether that square is under attack with those queens. That's it.
So you calculate I plus 1, I minus 1,
We'll see how I do
j
that.
minus 1, j plus 1, all
Why
those.
I minus 1, I plus 1?
Because, I mean, the
A queen can attack anywhere. It's not just what, plus 1, plus 1.
Yeah, okay. Then there.
Yeah, an entire diagonal as well. Right? Okay, let's just look at code. It becomes clear once we do that. Okay, so here, yeah, this is my final answer. I declared it as part of my class because it's integer. This is the current state. This is the recursive helper function call and then return. Okay?
Only when the list is of size n. Total n queens plus plus. What is total n queens?
So total n queens is total number of n queen
Oh,
solutions. Okay? So if I can put a queen on the last file, that means I have a solution.
That's one of the solutions.
Right? So that I have this. Okay? Now, curve queens is a list of integers, and whatever its size is, if its size is 5, that means I already put 5 queens in 5 files, and I need to find the position for the 6th queen. Right? So I iterate from I to n for each rank. Okay? And if I can put a queen in this I rank and whatever 5, then I add it because it removed.
But that function is
Yeah. So this uses another helper, but I broke it into like good, meaningful parts.
So, but every time you check from 1 to n, like what if you start like what was his last?
no.
Okay, but it any other okay.
This
so
is only for the starting, coming the first.
This is the rank.
Yeah.
So now I need to put a queen in the file number queens.size.
So you actually try to iterate for every
Every row, that's it, every rank.
Every
row
box,
basically.
right? Oh.
See, I'm putting, if I put a queen, I know I'm going to put it in a certain file, and that file is basically how many are there plus 1. So right now if I have 5 queens already in this, That means I'm trying to put a queen in the sixth file. Is that clear? Sixth column.
Sixth column.
Yeah.
And this n
I
iteration
successfully
is
put
for-
queens in like one column after the other.
Yeah, but this n iteration is for
For the
all,
rank, for the row.
for all the
Rows
possible-
in the sixth column.
So,
So in the sixth column I have n candidates, right?
so that new queen pos is going to check whether it is an attack position
Yes,
or not. right?
from the previous queens that I've already placed.
Yeah.
So can the queens be in the same row
No?
and not even the same column?
Yeah, and not even the same diagonal. That's it.
Okay.
Okay?
So that's what I was asking you, why you're like iterating from 1 to n at least
Because at
because
this point, I do not know which are the squares that are not
That
available.
are not applicable. So that
Okay.
if we'll
You have
check
to
that and return
Yes.
back.
Yeah.
So how does column iteration happen? How the column, I mean, you say like if, where do we do that +1 for column?
No, you're not doing any +1 for column. So if I give you a list, can you go from that list to a chessboard?
Okay,
You
so
can.
you basically, the list size is the.
Exactly, yes. So the list size tells me how many queens have already been placed. Okay? After the standard backtracking, adding, recursive call, removing. Okay? Do you guys want to see this?
Yeah.
Okay. So it's very simple. I have a new rank and I have a list of queens. Okay? And the new file is whatever, its size.
Can you say what is a rank and what?
Okay, rank is row, file is column.
Okay.
That's all. Okay? Now I have a helper function which is very simple. It takes one index, another index, and can you have two queens at those indices without attacking each other? Two positions in the chessboard basically.
Okay.
you have to check the
Okay? If those two positions are on the same row, then they are under attack. Those two positions are on the same. Okay, this is both row and
This
column.
is rain.
Yeah.
Oh.
And this is if they are in the same diagonal. If they are in the same diagonal, then the difference between columns is same as difference between rows.
How is that?
Yeah, so let's say you have where is the okay. Let's open it again. So let's say you have two queens here and here. Okay, anywhere on the same diagonal. Same diagonal means the number of rows is 1, 2, 3, 4. Number of columns is also 1, 2, 3, 4.
Oh.
So two queens along a similar diagonal means the absolute difference between their rows is the same as the absolute difference between their columns.
So, okay. Then one of these will not match. So it is also like. 0, 0 and 4.
4? Yeah.
4, 4 are.
Yeah. On the same diagonal. Okay, so that is this simple helper function. But how am I using that? Is very simple. So I need to know the row and column of the queens so far, and the row and column of the new queen that I'm putting it in.
Oh, for each queen we have to.
Yeah. So the row and column of the queen that I already have is whatever get off is the row number, right? Okay, now we are not doing zero based index. It's 1 to 8, 1 to n, 1 to n.
Oh.
1 to n rows, 1 to n columns. Okay? So I literally put like 1 to 8, whatever row is there, I would have already added.
Is it when you add, you put a +1?
Yeah, it's +1 because this is 0
No,
base.
for the list also.
No, for the.
In current queens list,
Yeah.
you added.
Yeah, I already added with +1. Yes. Yeah. I choose like consistent notation, chessboard notation, 1 to 8, 1 to 8. Okay? And last file, it's last file +1 because its size will be based on the 0 based index system. No, it's not 0 based. So if there are already 5 queens that I put it, the new queen is going to be on the 6th column,
Column.
right? So size +1.
It's in.
Yeah. And that is the new row.
So when we have to do the n queen problem,
Yeah.
without like just not the total.
Okay. Then it's very simple.
Then we shouldn't do this plus 1.
No. You have to do this.
Then how do we print the final matrix?
Yeah. So you print the final matrix here. So instead of doing total n queens plus 1, you just take that list, and that list tells you all the positions of the queens.
Yes.
Yeah, once I have the positions of the queens, I can draw it in that stupid way.
Then there we have to do that I minus 1, right? To place it in a matrix. Matrix starts with 0 index.
Yeah, you have to do that. Yeah, maybe in that case it makes sense to.
Yeah, we need not have the plus 1.
Yeah. Do you guys get that question? Okay, that's fine. Okay, any questions about this, or do you want me to spend more time, or? Okay. Yeah, this is so cool. Like after I solved this problem, I asked my parents to send me like Sudoku puzzles from like newspapers, Hindu, and I just instantly tell them the solution. This is awesome. You can solve Sudoku by backtracking. Yeah, so okay, how many here do not know Sudoku? The rules of Sudoku?
It shouldn't,
Yeah.
one column should not have repeating
Yeah.
number,
Okay.
one row should not have repeating number,
Okay.
diagonal should not.
No.
Diagonal can have.
Yeah, it's this
And
3 by 3
this
square.
square.
Yeah.
Oh, diagonal can have repeating.
Yeah, then it will be n queens only.
Okay.
Yeah. Okay. So you guys know what question I'm going to ask you. What is the question I'm going to ask you?
State.
Yeah, how do you define each state? So right now this is input. The input is they give you the skeleton.
Partially filled.
Yeah, partially filled numbers, exactly. And the unknown unfilled numbers are dots.
Okay. Oh. So for every dot,
Yeah.
what is the number? We have 9 possible. Okay, we have 10 possible numbers.
Yeah.
So that is the state.
No, we have 9 possible numbers, by the way.
0 is none.
Yeah, so 1 to 9.
Oh.
Yeah.
So 9 possible numbers.
Yeah.
So for 9 possible numbers, we are going to proceed. For each possible number, we are going to build it.
Yeah, how? So what is your, first of all, okay, conceptually what is your state?
The fine matrix.
Okay, this box
Yeah.
with numbers, some of the numbers filled.
Okay.
Because I'm asking about the intermediate state. See, I'm asking about intermediate state because when you're coding, you code for any intermediate state, I and j, right?
Okay.
So that's why I want to map these abstract ideas to code. So your intermediate state is where you filled some of the numbers.
Okay.
Then you get more specific. Which numbers do you fill? Do you fill these 2 numbers or do you fill these 5 numbers? So like, yeah, so come up with a good strategy for which numbers you fill.
You should go into the model.
Yeah, let's just go in that order. That's it. Yeah.
Just row.
Yeah, I start, or you could start with the first column. It's really up to you,
Okay.
but pick something that's intuitive. So as I go along like row by row, I see the first dot and I try to fill a candidate for it. Okay, so the intermediate state will be like maybe up to like the 4th row filled, and maybe I need to fill this guy.
Okay.
Okay, so what are its children?
9 children. Right.
Yeah,
But
9 children where this dot has,
what-
where this dot is filled. Yeah.
Yeah.
Yeah. So if my current node is everything filled up to this point, then my children will be all 9 possible candidates for this guy. Okay? But then would every single number like fit in that slot?
No.
No, only one number will fit in that slot. Because finally it's only one unique solution.
Yeah, but that we won't know, right? At one intermediate state, we can
Yeah.
have 2-3 branches, right?
Yes, that's true. But in the final
So the
answer,
final answer, it's going to be
this
just
is only going to be one
so
number.
one. Only one will reach the
Exactly.
place where all elements
Everything
are
is
filled.
filled. Yeah. Yeah. So so what do you need to do then? You have 9. You have
We
9
just have
candidates.
to have only those leaves that matches the condition at that point.
Exactly. So you are again like same as n queens. But instead of checking the new queen position, you check to see if I can fit 5 here, 4 here, with those rules. Yeah. And how do you want to, coding those rules was slightly tricky for me, but it's a good learning experience. Yeah.
Oh.
Yeah.
Oh, we need to have a list of numbers set of numbers in a row, set of numbers in a column and all.
You already have a matrix. So yeah, all of those things will make your computations faster. It's really up to you.
Okay.
Yeah, if you have the set of numbers that I've seen so far, that helps.
I mean in a row.
But then you have to have duplicates, right? You anyway have your master data structure, the character array, with all these numbers and dots.
Yeah.
Okay? On top of that, you have to duplicate the data.
Yes.
You have to have a list for this first row alone, this row alone.
Yeah, but in an array we still have to iterate and see every time, right?
Yeah. Yeah, again, it's just a trade-off.
Okay.
Yeah. It's not part of the strategy of how you want to solve it, right? Yeah. Wait, what was another thing I wanted to discuss? Yeah, you check to see if it passes the test. Yeah. Another thing I wanted to discuss is, so how you are going to proceed is, here you are going to try to put 1. Okay, if 1 fits, then here you are going to put 2. Then here you are going to put 4. You are going to put 6. Whatever, you guys get it, right? And that may not work out. That may not be the final solution.
Yeah. So
Then you come back again.
And then put 2.
Yeah.
And then fill 1.
Yeah. So when you come back, how do you know whether that passed or not? Yeah, that's the tricky part.
So we just have one solution per sure.
Yeah.
Yeah, you only have one solution, exactly. So in n queens, I know that I have many solutions. So I explore all paths and I accumulate
So
all.
if we have found the solution, we can break and exit.
Exactly. So how do you want to?
Maybe have the final.
Yeah, final
yes,
answer as
null or something.
or whatever, boolean or whatever. Yeah, that's it. Yeah, you have to have that extra check. That's it. Okay, it's 4:52. We can't code this. Let's look at the solution. The solution is a little big.
Oh, so checking the
Yeah, so this is very, very brute force. So for every call, I start from the beginning. Actually, I don't have to do that. If we have a strategy going forward that I only fill out row by row, then for every subsequent call, I put out the new row and column where you need to start. Right here, I'm starting all the way from the beginning for every call.
But you need this loop, right?
No, you don't need. Yeah, you need this loop, but you don't need 0 and 0, 9, 9. You can start somewhere like 4, 4. Because
What if the first position is a dot?
yeah, so the first position gets filled, and then for my next call, I send first row, second column as an input. Actually, let's make that change right now.
Can
no,
you
it's
go,
not
I mean,
like
this is not, can you go to the main function?
The main function is just declarations, and yeah, it's not even a declaration.
But you
Wait, why do I even have this?
So
Okay.
that is why you have for loop like this here. You need to iterate and see which is the first empty position, right?
Yeah. So the thing is that's what I was discussing. So the first empty position, okay, where are you? So right now, if I want to fill this position, I'll only be filling this position if I filled all of these.
Yes.
So I need something that tells me, okay, you need to start filling from this point. So right now what I'm doing is, I fill this, okay?
Oh, you say like
One second.
I is equal
One
to,
second.
okay.
I fill this,
Huh.
and then I make a recursive call. That recursive call does not know I need to fill this. That recursive call starts again from here.
That's what. So you need I equal to some position and J equal to
Yes.
some position.
Yeah.
Okay.
To capture the state and to tell its children where to start from. So that's what was missing. So you guys let me know, like, code it with the strategy I described and let me know if it works. Yeah, so yeah, I'm doing a lot of extra work. But yeah, here instead of a global boolean, I make this guy itself return a boolean. So this guy returns a true, that means that path led to a valid solution. And if that path led to a valid solution, then this guy also returns true for this C.
What is
Valid solution? How do you define valid solution?
Okay, a valid solution is if it returns true. Yeah, I returned true here. That means there were no dots. I never even went inside this if. That means there are no dots. Then I just return true. So after filling the last integer at the last corner, here, I make another call. And this call will return true.
Okay.
Yeah. So that's why if you have like those indices row and call to be filled, then you can just check if that row and column is the last row and last column. If it is, then just exit. Yeah, that's it.
Can we go to the valid?
Yeah. Yeah, okay, yeah, that's the fun part. Okay. Yeah, so
If that is simply if the row or column.
yeah, so first of all I have a row and column, right? So I go through every element in that same row, every element in the same column. If you already have that character, then just return false. Okay?
Then we have to check for the box.
This
Yeah.
is diagonal.
Yeah, no, it's not diagonal,
Sorry,
it's the box.
that's, the subportion.
Yeah, okay, for one sec, I'll move to the diagram, but the diagram will make it clear, okay? So right now, if I have a candidate here, I need to know all numbers in this box.
So Sudoku will always have just 9 blocks, is it?
Yeah,
Yes.
So it is divided by 3.
yeah, one sec. So right now, any square in this box should converge on this box. I should know which is the box, right? For any square in this box, or any square in this box. So that math is basically for that. So these indices are 0, 1, 2, 0, 1, 2. Okay? So based on whatever is the row, it's for 0, 1, 2, I need to know that the rows are 0 to 2. Okay? So I divide by 3. So 0, 1, 2 divided by 3 is what? 0. And 0 times 3 is 0. So I get the minimum row as 0 and the maximum row as minimum row plus 2. Okay? Now let's say I have columns 3, 4, 5. Okay? For any column 3, 4, 5, minimum row is 3, maximum row is 5. Right? So again I divide by 3. 3, 4, 5 by 3 will give me 1. Times 3 will always give me 3. And that's similar math for column. And that's it. In that box, I try to see if I have a C again.
So this intuition by yourself.
Yeah, this I calculated by myself. Like math. Yeah.